Okay, good day to all grade 10 students of Pablo S. Villaferte High School. Again, this is your science teacher, Sir Eduardo D. Mali Jr. And today we are going to tackle all about the Quarter 2 Module 3. So I hope you will enjoy all the quizzes and games included in this module. And I hope that while you are learning, you are enjoying our lesson. Our most essential learning competency in this module is compare the relative wavelengths of different forms of electromagnetic waves. Have you ever wondered why a rainbow disperses different colors? So we have the Roy G. Bibb. As if you're going to review the colors of the rainbow, the Roy G. Bibb, the red, orange, yellow, green, blue, indigo, and violet. Well, what we see are called the visible light. But this is just a small part of the whole electromagnetic spectrum. So in this module, you will learn about the different regions of the electromagnetic spectrum or the different members of the electromagnetic spectrum family. For our targets, or describe the different regions of electromagnetic spectrum as to wavelength, frequency, and energy. So just remember those three terms, the wavelength, frequency, and energy. Okay, before we proceed to the different activities and exercises in this module, let us check first the try this or the pre-test. I'm going to read the questions, and while I'm reading the question, you have to suggest in your mind what will be the possible answer. And let us check also your answer if your answers are correct. So let us read number 1. Which of the following is the correct sequence of electromagnetic waves in the electromagnetic spectrum? What do you think is the answer? Is it letter A, radio waves, gamma rays, X-rays? Or letter B, the arrangement letter B, radio waves, infrared, microwaves? Or the arrangement letter C, radio waves, visible light, followed by UV rays? Or the arrangement D, from radio waves, X-rays, followed by UV rays? What do you think? Let us check. Okay, you're correct. The answer is letter C, radio waves, visible light, and UV rays. Okay, let us proceed to number 2. Which two waves lie at the ends of the visible spectrum? Meaning, it is in the left and right side of the visible spectrum. Is it letter A, infrared and UV rays? Letter B, radio waves and microwaves? Letter C, radio waves and X-rays? Letter D, X-rays and gamma rays? What do you think is the answer? Okay, letter A. That is infrared and ultraviolet rays. And as we go forward with our discussion, we will learn it more. Why is it that letter A is the correct answer in number 2 and why is it that letter C is the correct answer in number 1? Okay, let us now proceed to number 3. Which of these electromagnetic waves has the shortest wavelength? A, infrared, B, radio waves, C, X-rays, D, ultraviolet waves? What do you think? Okay, correct. Letter C, X-rays. Among these four givens, just remember, among these four givens, X-rays has the shortest wavelength. Okay, and number 4, compare to the wavelength of ultraviolet waves, the wavelength of infrared wave is, or if you are going to compare ultraviolet and infrared in terms of wavelength, the wavelength of infrared waves is blank. A, shorter, B, longer, C, the same, D, cannot be determined. What do you think is the answer? Okay, you're correct. It's letter B, longer. And number 5, which of the following is true about gamma ray? Letter A, it has the shortest wavelength. Letter B, it has the longest wavelength. Letter C, it has the lowest frequency. D, it has the lowest energy. Can you give your answer? Okay, that's correct. Letter A, it has the shortest wavelength. So I hope you enjoyed answering our 5 pre-test questions. Okay, let us now proceed to the first activity, the puzzle game, or do this. In our directions, study the picture shown in column A, then arrange the jumbled letters in column B to reveal the type of electromagnetic wave depicted by the picture. Okay, what do you think is the correct answer? And number 1, what do you think, what kind of wave is this? And in this arrangement, what word do you see? What kind of wave? What is your guess? Okay, let us check. Okay, the answer is radio waves. What about in number 2? What do you think is this picture? Is it the sun? So what kind of wave is that? Okay, let us check. Ultraviolet waves, that's correct. Okay, in number 3, as you can see, as I mentioned a while ago about rainbow, we have the different colors of the rainbow. Can we see the colors of the rainbow? Yes, of course. What kind of light is that, or what kind of wave is that? Okay, correct. That is visible light. Okay, what about in number 4? Maybe you have this kind of appliance in your home. What kind of appliance is this? Okay, correct. Microwaves. Okay, what about this? I think you are so familiar about this. There is X-rays. Okay, what about this one? Okay, correct. Infrared. What about in number 7? What kind of ray is this? Let us check. Okay, gamma rays. I hope you enjoyed answering this activity number 1. Letter B activity, word search directions. Find the words related to what you know about electromagnetic spectrum. Write your answer on the space provided below. Or you may write your answers on your activity notebook. Words can be found written across, left or right, up and down, and diagonal or diagonal down. So, I'm going to give you example. Okay, we have, what word is that? Okay, correct, microwave. Okay, another example. The word is gamma ray. And the rest, you will be the one to find what are the different words that you can find which are related to the electromagnetic spectrum. Okay, I am giving you time to answer that. Okay, I hope you enjoyed answering this activity, the word search. Okay, let's arrange me. The title is arrange me. Direction, arrange the EM waves in the table as indicated. So, we have 3 columns. The first one, shortest to longest wavelength. So, you're going to arrange the members of the electromagnetic spectrum family from the shortest to longest wavelength. In the column B, from increasing frequency, meaning from smaller amount of frequency to highest amount of frequency. And in the third column, decreasing energy, meaning from highest energy to lowest energy. So I'm going to give a sample in each column. For example, in number 1, the shortest is the gamma rays. So what will be the next? What will be the last? What about in the increasing frequencies? Okay, the example is microwave. That is in the second part, in increasing frequency. So in decreasing energy, the last one is the radio waves, meaning radio waves has the lowest energy among the members of the electromagnetic spectrum family. So, I am suggesting that you continue watching this video because after discussing this part, the electromagnetic spectrum family, this part, you may go back to this table and complete, or the electromagnetic spectrum is simply the full range of wave frequencies that characterizes solar radiation. Although we are talking about light, most of the electromagnetic spectrum cannot be detected by the human eye. Even satellite detectors only capture a small portion of the entire electromagnetic spectrum. From longest to shortest wavelengths, the spectrum is usually divided into the following sections: radio, the microwave, the infrared, the visible, ultraviolet, X-ray, and gamma ray, or the gamma ray radiation. Humans can only see a narrow band of this visible light, which is a small fraction of the electromagnetic spectrum. We perceive this radiation as the colors of the rainbow, ranging from red to violet, reds having longer wavelengths, approaching 0.7 micrometers, and violet having shorter wavelengths, approaching 0.4 micrometers. But keep in mind how long these wavelengths really are. When we say 1 micrometer, okay, this unit, when we say 1 micrometer, is equal to 1 millionth of a meter. So imagine 1 meter stick, divide that 1 meter stick into 1 million part, that is 1 micrometer. That meaning 1 micrometer is so small that even our naked eye cannot be able to perceive, which is approximately 1 over 100 the diameter of human hair. So that's so small. For example, microwaves are on the order of 1 centimeter long, and television and radio waves have lengths greater than 1 meter. Okay, in this table, table 1 shows the relative wavelength, frequencies, and energy of each of the different types of electromagnetic waves. So, this column, the members of the electromagnetic spectrum family. In this column, the wavelength. Okay, let us, from radio wave, this is greater than 1 times 10 raised to negative 1. That is the wavelength. What about the microwave? 1 times 10 raised to negative 3 to 1 times 10 to negative 1. So between this size, meaning microwave has shorter wavelength compared to radio wave. Why? Because the exponent of this is negative 1. The exponent of microwave is from negative 3 to negative 1, meaning the negative 3 is smaller than the negative 1. O infrared, 7 times 10 raised to negative 7 to 1 times 10 raised to negative 3, meaning much shorter compared to microwave. And visible, 4 times 10 raised to negative 7 to 7 times 10 raised to negative 7. And UV rays, 1 times 10 raised to negative 8, 4 times 10 raised to negative 7. And X-ray, 1 times 10 raised to negative 11 to 1 times 10 raised to negative 8. And the shortest wavelength is less than 1 times 10 raised to negative 11. That is the gamma ray. So, gamma ray has the shortest wavelength and radio wave has the longest wavelength. Let us now proceed to the frequency column. So, in radio wave, less than 3 times 10 raised to 9. As you can see, the microwave, meaning the microwave has higher frequency compared to radio wave. It is 3 times 10 raised to 9 to 3 times 10 raised to 11. And infrared, 3 times 10 raised to 11 to 4 times 10 raised to 14. Visible light, 4 times 10 raised to 14 to 7.5 times 10 raised to 14. UV rays, 7.5 times 10 raised to 14 to 3 times 10 raised to 16. X-ray, 3 times 10 raised to 16 to 3 times 10 raised to 19. And the gamma ray has the highest frequency among the electromagnetic spectrum family. This is 3 times 10, greater than 3 times 10 raised to 19. So if we are going to relate the wavelength and frequency, as the wavelength decreases, meaning the frequency increases, they are inversely proportional. So if we are going to increase the wavelength, that the frequency decreases. As you can see, radio wave has the longest wavelength, it has the lowest frequency. The gamma ray has the shortest wavelength, it has the highest frequency. Okay, let us now proceed to the energy column. It is in the unit of joule. Okay, the radio wave is less than 2 times 10 raised to negative 24. Then, check every value. It is becoming higher. So, meaning radio wave has lower energy compared to microwave. And microwave has lower energy than infrared. So, as you can see, as we go downward, the gamma ray has the highest amount of energy, which is 2 greater than 2 times 10 raised to 14, negative 14. So, meaning, the higher the frequency, the higher the energy. The lower the frequency, the lower the energy. As you can see, wave has the lowest frequency, meaning it has the lowest energy. And gamma ray has the highest frequency and it has the highest energy. And if we are going to compare again to wavelength, meaning if the wavelength is longer, the frequency and energy is lower. And if the wavelength is shorter, meaning the frequency and energy is higher. So we can now see the interrelationship among the three: the wavelength, the frequency, and energy. Okay, we have some tips to help you remember the electromagnetic spectrum. So the arrangement of these 7 members of the electromagnetic spectrum family, from radio wave to gamma ray, we have Raja's mother is visiting Uncle Xavier's garden. Much better if you're going to memorize the arrangement. So, as you can see in this picture, the wavelength from radio wave, microwave, infrared, visible, ultraviolet, X-ray, it becoming shorter. From left to right, the wavelength becoming smaller. Okay, let us take a closer look in this electromagnetic spectrum. Okay, as you can see, again, the wave from radio wave, it has the longest wavelength, becoming shorter and shorter and shorter and shortest to gamma ray. So, as you go to the left, the wavelength becomes longer. As you go to the right, to gamma ray direction, the wavelength becomes shorter. Okay, what about the energy and the frequency? Okay, as you can see in this value, the frequency becomes lower in this direction and become higher in this direction. So as I said a while ago, the longer the wavelength, the lower the frequency, and then the lower the energy. The shorter the wavelength, meaning the higher the energy, and then the higher the frequency. I hope you understand the interrelationship among wavelength, energy, and frequency of electromagnetic spectrum members of the family. Let us now proceed. Apply what you have learned. Okay, in this part, you will be the one to answer this in your activity notebook. I hope you fully understand what is all about the electromagnetic wave and the description of each members of the electromagnetic spectrum. So, in this table, we have two columns. Our direction, compare the relative wavelengths, frequencies, and energies of the different regions of the electromagnetic spectrum. So, if we are going to compare the frequency and then the energy, we are going to use the lower or higher word. And if it is pertaining to wavelength, we are going to use the longer or shorter word. So you have to choose. So like in number 1, radio wave is blank in wavelength than gamma ray, meaning you're going to choose between longer and shorter. So your answer will be longer or shorter depending on the correct answer based on our discussion. And number 2, microwave is blank in energy than infrared, meaning you're going to use the lower or higher. Number 3, visible light is blank in frequency than X-ray, meaning you're going to use the lower or higher between the two you're going to choose. Number 4, radio wave is blank in energy than gamma ray. 5, ultraviolet rays in wavelength than infrared, or blank in wavelength than infrared. Number 6, visible light is blank in frequency than radio wave. So to my students, you have a printed copy of this. You may take a closer look in the graph of the electromagnetic spectrum, or you may go back to this video. Okay, let us proceed to match up letter B. We have again 3 columns. In the first column, you are going to put your answers. So you are going to write only the letter. So write the letter of the correct definition found in the third column for each word found in the second column. So in number 1, ultraviolet. Okay, from A to J, which of these describing ultraviolet? So if you choose a letter, put your answers here. And number 2, microwave. Number 3, infrared, gamma ray, X-ray, radio wave, visible light, electromagnetic spectrum, frequency spectrum. So based on these different definitions, okay, congratulations, you have completed the electromagnetic spectrum lesson. This time, share your insights to the class. So now we are not in the face-to-face classes. You may now write your reflection on your activity notebook, or you may comment down here in comment box about your learning. So if you have question, you may also ask question. I have learned that and I wish to ask my teacher about. Want further information about our topic? You may ask questions here, and to the best knowledge that I can, I will answer all your questions. Okay, reinforcement. What happens when a person is exposed to M waves? Write your answer in essay format. Or you may also comment down here your reason or your answer. What happens when a person is exposed to EM waves? Okay, for our vocabulary list, the following terms used in this module are defined as follows. Dispersion of light. This is the splitting of white light into its constituent colors due to the refractive index of the surface in the wavelength of the light. So meaning this is the separation of the different colors of light from white light. Electromagnetic spectrum. A continuum of electromagnetic waves arranged according to frequency, wavelength, and energy. Electromagnetic wave. A disturbance in a field that carries energy and does not require a medium to travel. Okay, frequency. The number of cycles a wave completes in 1 second expressed in hertz. Okay, the unit of frequency is hertz. This is the number of cycles a wave completes in 1 second, or when you say frequency, the number of wave passes through a given point at a given time. So that is the count of number of wave that passes in a given boundary at a given time. So that is frequency. Okay, wave. A disturbance that transfers energy. Or this is the carrier of energy when you say wave. Wavelength, the distance measured from one crest of a wave to the next crest, or from one trough to the second trough. Okay, let us now proceed to the assessment. Okay, assess what you have learned. Okay, identify what is asked or described in each item, then write the letter of the correct answer on your answer sheet or on your activity notebook. Number 1, which electromagnetic wave carries more energy than the others? Which do you think has the greatest amount of energy? Is it the microwaves, the radio waves, letter B, letter C, UV rays, D, visible light? And I'm pretty sure that you answered this correctly. Okay, number 2. What EM wave comes between microwaves and visible light? Is it letter A, gamma rays, B, infrared, letter C, visible waves, and letter D, X-rays? Okay, and number 3, electromagnetic waves are arranged in EM spectrum according to which of the following? Is it increasing wavelength, decreasing energy, increasing frequency, or unidentified? What do you think? Is it letter D, unidentified? Okay, number 4. Which of the following is true about gamma ray? A. It has the shortest wavelengths among the others. Letter B. It has the lowest energy. Letter C. It has the lowest frequency. Letter D. It is found next to radio waves and EM spectrum. And in number 5, which of the following is the correct sequence of EM waves and EM spectrum? Letter A. Radio waves, gamma rays, X-ray. Letter B. Radio waves, infrared, microwaves. Letter C. Radio waves, visible light, UV rays. Letter D. Radio waves, X-ray, UV ray. Okay, for our next video lesson, for our next topic, we are going to tackle all about the module 4 of the quarter 2, which has the topic of characteristics of electromagnetic waves. Okay, again, thank you for watching. This is Sir Eduardo D. Mali Jr. Thank you for watching my video.